As promised in the last video, we will step through a Monte Carlo simulation where we choose a model with some input, one or more inputs and one or more outputs. We'll randomize the inputs, and then we'll do some Monte Carlo simulation with data table on a blank cell. Let's choose a model, everybody's favorite model, the course grade model. Let's talk about randomizing a couple of inputs. I want to randomize quiz 4 and the final exam. Those are the ones we played with earlier in the course. And see what it does to the output of course average. Now when I say randomize these, remember our picture of the function machine technique. This is where instead of putting an 85 or any other deterministic number into the model, we're going to have the model sample this input. In this case we're saying final exam, between 85 and looks like it get down, I don't know, maybe these normal distributions go on forever, but it looks like generally going to be between 75 and 95. I could actually write that by saying Excel, pull from the normal distribution, actually the inverse normal distribution, some random probability with a mean of 85 and a standard deviation of 5. And what should that tell us? That should tell us that if I were able to take the final exam many times and not learn from it and get better, but if I were able to do this in, let's say, 1,000 parallel universes, then about 2/3 of the time I would expect to be within 5 points of that 85. So 2/3 of the time, or let me say it this way, I have a 2/3 confidence that I'll be between an 80 and a 90. And then about 95% of the time, I'll be within 2 standard deviations of the 85. So I have about a 95% confidence that I'd be between a 75 and a 95. And then 99.7% of the time, or let me say I have a 99.7% confidence that I'll be between a 70 and a 100. And if those numbers seem completely arbitrary to you, go out and do this for me. Google 66, 95, 99 and see what comes up. If you go to images, you're going to see all kinds of pictures that remind you of the statistics class you took where they explained this and what a standard deviation really means to the normal distribution. I won't review it here, but if you want to, just Google those 3 numbers and you'll learn as much as you want to about it. For my purposes, it just says if I expect to make an 85 with a standard deviation of 5, I'm about 2/3 confident I'll get a B. I'm about 95% confident I'll be between a 75 and a 95, and I'm virtually certain I'll be between a 70 and a 100. If virtually certain is not good enough for you, if the 0.15% of the time or probability that I could be over 100 bothers you, consider there's about a 0.15% chance that I might give a bonus on the final exam. And just like before, when we hit F9 to recalculate, it samples a different number from that distribution. So let's copy that, or I'll tell you what, I'll show you that formula first, and then I can copy them both up to quiz 4. In quiz 4, I'm going to put in some different numbers. I've done pretty well on the first 3 quizzes, so I'm not going to spend too much time on quiz 4. I think I'll make a 70, but I have a lot of uncertainty around that. I'll give it a standard deviation of a 10. And so quiz 4 has a lot more uncertainty and a lower expected value. The final exam has less uncertainty and a higher expected value. Now let's do our data table on a blank cell. Recall that means starting with iterations, putting a yellow blank cell that we can use to put our inputs, and then counting up to 1,000. 1,000 iterations. And each time we recalculate this model, I would like to see how I did on quiz 4, how I did on the final, and how I did in the course. And so I'll get quiz 4 from right here, get the final from right here, and I'll get the course grade from right here. And then when I run the Monte Carlo simulation, it's kind of meaningless, but each time we put one of these iterations in this blank cell, it causes all these numbers to recalculate and get listed over here, and that's how we do Monte Carlo simulation, even if we forget to format those as outputs. So we now have the iteration data. going to center that across the selection. I hate to merge cells because it causes all kinds of problems later, but center across selection works well. And then I can do Alt HBA to put all the borders around them. We've done our iteration data. Now it's time to go into step 4 and calculate a column of running average and create a convergence chart. Let me copy these headers and call this running average. The running average for quiz 4 would just be the average of quiz 4 from the top line to the current line. And if I lock the top line but only the row, then I can copy this and copy it all the way down by double clicking, and then I can copy, paste. If I check one of these random ones down here, see how it worked. Sure enough, for the course grade, I'm calculating the average from the first iteration down through the 6th. So if I wanted to see how well did quiz 4 converge, in other words, did I run enough iterations to get this average to settle out? Because one iteration had me 5 points from the mean. The next one got me further away, and the third one even got me further away. So the first 3 times I sampled that distribution were significantly above the mean. The 4th time was at the mean, and then I started sampling below the mean for a couple. And so this running average needs to get to 70, because we would expect if we sample from that distribution enough times, we get exactly 70. If I go all the way to the bottom with a control down, I could see that after 1,000 iterations, it is getting pretty close to 70. I don't really know how many it took to get there. So let's draw a picture of it. Let's do a control shift down, hold down the control key and click on this cell, control shift up. I'll wheel that mouse up a bit. And then I can insert a chart with Alt N for insert and D for XY scatter chart. Not sure where they came up with that. If you try this and it doesn't work because you chose a line chart, please don't call me. Just come back and choose an XY scatter chart. And what it says is, gosh, if you just do a few iterations, that average is all over the page. But you know, after 200, 400, 600, eventually it looks like it's going to converge around 70. You know, if I were investing money based on this, I may even want to run more than 1,000 iterations until I saw a nice flat line there. As I'd mentioned in the other video, there are more complex ways to think about that problem, but we won't do it here. I'll go through it quickly, but I want to make one of these charts based on these other 2 columns as well. So let me make this one smaller. Get that font size a bit smaller so we can see what's going on. Now I'm going to control and click and drag. Control and click and drag. That's the easiest way to copy things in a lot of these Microsoft products. And then if I click on these cells, I can move that range of data just like I would in a formula to the final. And now instead of quiz 4, I'm showing the final. And if I click on these blues, I can move this one to the course. And instead of quiz 4, I'm showing the course. So I've now calculated the running average and made the convergence charts. And to the extent that I care, I could spend a lot of time thinking about, did they really converge? But I'd rather move to the next step and say calculate a column of percent rank and create the cumulative probability charts. So let's copy this, call it percent rank. And remember, that was the percent rank.inc function where we ask for the data. Now, since I'm going to copy this down, I need to hit F4 to lock the rows, but I also want to copy it to the right, so I'll hit F4 again to unlock the columns. And then I'll hit comma and say I would like to know in this cell how this number ranks. And then everywhere I copy that cell is going to be relative to that, so I don't want any $signs on it. I'll just hit enter. Same thing, I'll double click, copy, shift right, paste. And now we've got percent rank for each of these. This time we'll want to plot the rank, or the probability, of getting a number less than that, less than this, against this. So I'll do a Control Shift down, click Control, or let me say Control click, and then Control Shift up. Roll my mouse wheel up a little bit, or hit this button a couple times so that we can see it. And again, we'll go to Insert, XY Scatter Chart. If you try this and it doesn't work because you clicked on that line chart, please don't call me. Just come back and use an XY Scatter Chart. And you can see that we have probability of getting something less than this number on quiz 4. And we call this a cumulative probability chart. We're never going to have any probabilities greater than 1, so why don't we double click on that and scale it from 0. Right now it's automatic, and I don't want it to be automatic. I want it to be actually 0. The easiest way to make it not automatic is just get rid of a decimal place, hit Tab, come over here, hit 1, hit Tab, and now these are no longer automatic. If I wanted them automatic, I could reset them. And what this says is that if we're thinking about getting a 70 on the quiz, it looks like there's about a 50% chance we get less than that, which means there's a 50% chance we get higher than that, which means we did a pretty good job with our randomization of this variable. It says that if we thought we could get a 60 on the quiz, that's about a 16% chance that we'd get something less than that. And notice there's about a 16% chance that we'd get something greater than an 80. Think about that 66-95 rule again, and you'll realize that we've done a good job of representing the normal distribution. Let's duplicate this thing a couple of times by clicking, hitting Control, and dragging. Clicking, hitting Control, and dragging. Change this data to this column, and this time we also have to change the X data, of course. And then change this data to this column. Change the X data, of course. And it so happens that this is a really important one because this is our course grade. We might want to go back and see what the distribution on the final was. But for right now, let's talk about the course grade. And so now we're saying that there's about a 50% chance that we'd get less than an 88.43, something like that. What are the chances that we would get less than a 90? Well, they're about 96%. So that says there's about a 4% chance we'd get an A in the class, and a just about negligible chance that we would get a B in the class coming in with these kind of expectations. And now we've made our 3 charts for the cumulative probability. And the next thing is to make some histograms. And we do that by binning the data. So let's start with quiz 4. We'll need some bins, and we'll calculate some frequency. I'm going to go ahead and center that across the selection again. By the way, a quick way to get there is Control 1. Don't know if that works on a Mac or not. Select that again and do an Alt HBA to put borders around all of it. I don't have to use the same bins for all of them, but I'm going to just to save time here. Let's calculate the frequency. So the frequency of quiz 4 output against these bins looks like this. And again, if your version of Excel is not new enough to populate that entire array at one time, look up array formulas and frequency, or see me for help. And we could use that to draw a histogram. So select the data, and this time Alt-N for insert, but instead of D for XY scatter chart, I'm going to hit C1 for column or bar chart. I'm just going to choose the first one there. It's called a clustered column chart. And it gives us our histogram. Of course, a histogram shows frequency versus, in this case, quiz 4. Now we'll copy this section, paste it here for the final. and paste it here for the course grade. Then I'll go in and adjust some formulas. So for the frequency, I want to use these bins, but this iteration data, see where my chart's looking. It's looking back over here. So it copied that chart when I copied the cells, but it left it looking at the same data. So I want to move these. And if you can't move those, I could move the Y, but I couldn't move the X. Click on the data series itself, and then you can move its X data. So same thing here. Want the frequency against these bins of this data. Stop and think about why. And then to fix the chart, I can move the Y data without selecting the series, but in order to move the X data, I need to select series. Now let's look back at our bins. We had a lot of uncertainty on, fix our labels here. And let's think about what happened. On quiz 4, we had a lot of uncertainty. We had a wide range of possibilities because our standard deviation was 10. On the final, we didn't have quite as wide a range of possibilities because we told it our standard deviation was 5. Now on the output, for the course grade, the model told us, well, all things considered, here's your range of outputs. You know, most of the work in this course is already done. These two are not correlated, so chances are you'll do poorly on the quiz and well on the final, or well on the quiz and poorly on the final. So to an extent, they kind of offset each other. See central limit theorem. And then you're left with a course grade with very little outcome. So let's go in and change our course grade bins to go maybe from 85 on up. 85, 86. Move this guy out of the way so I can copy these down to there. And now we get a little bit better character on our histogram for the final. And here I think I might go from 70 to 100. We can rescale these histograms by changing our bin sizes. So let's put them over here. In another video sometime we'll talk about how to align things.